In this session, we're going to look at lessons 80, 81, 82, and 83. Lesson 80, we're not going to spend a whole lot of time on because it's just building on this trig proofs, this trig identities concept. Once again, you need to go in your book and look at this one is on page 486. You can see where I've taken the blue pen there. Those are the new trig identities that you need to write down. You need to add two because you're going to need those in order to solve for these. I'll show you the first one, but these are the kinds of things we're looking at in class every day. So you can't possibly look at all the possibilities, but I'll just show you this one. Secant squared x minus tan squared x over 1 plus cotangent squared x. Show how it equals sine squared x. You look at it, you may get a little overwhelmed, but you just go over to your identities. And two identities we're going to look at. These are two of the new ones, two of the three new ones that they gave you. And this one's fairly easy. And we're still just introducing this concept, so it's not real difficult at first. Secant squared x minus tan squared x is actually an identity. That equals 1. Okay? 1 plus cotangent squared x equals cosecant squared x. And this is 1 over sine squared x. So whenever you flip this and bring it to the top, it equals sine squared x. So that is a proof. But the whole key is these over here and learning what to plug in for what. So that's all lesson 80 is. We're just building more on this concept. And once again, we can go over these more in class. Let's move on to lesson 81. Lesson 81 is one concept. It's actually an easy concept. This is called the law of cosines. And this law of cosines is going to help you to find missing pieces in a triangle. To this point, we've done the law of sines, which we will still use the law of sines. It's just the law of cosine helps us when we have some missing pieces where we can't do pairs. Okay, so remember, law of sines takes the side, 10, divided by the opposite, the sine of the opposite angle. Okay, another pair here is 7 over the sine of m degrees. Another pair is x over the sine of 36 degrees. Notice that we have no pairs. We have a missing piece on every single one of these. Whenever that happens, we're going to use the law of cosines. In the law of cosines, you have p squared, a squared, b squared, a times b, and p. Now, p, this is the angle. The rest of these are sides. And this angle will correspond with this side, okay? So we could use this one here. So we would have p squared, or if we use this as our angle, x is opposite that. So x would go here, x squared equals a squared, or 7 squared, plus 10 squared, minus 2, 7 times 10, cosine of the angle 36 degrees. So you simply fill in from the triangle to this formula. Super easy. You're just filling in missing parts into a formula, and then you work it out. So you have x squared equals 49 plus 100 minus, you have 140 cosine 36. So you put 140 cosine 36 into your calculator. When you do that, you get negative 113, or it becomes minus 113.26. We have 149 minus that equals x squared. You do the math there, you get 35.74. X squared equals that, square root of both sides. X, which is going to be your opposite, your 36 degrees, x is 5.98. Now, the one thing I do want to point out, okay, so we have now x is 5.98. Now that we have our pairs, we can use law of sines to solve for m and y. The one thing that I do want to point out here is, and let's just go ahead, let me throw the answers up there for you guys. Y is 100 and m is 43.47. This is 100.61. Let's throw it up there for you guys. So 43.47 and 100.61. So 100.61 is the biggest angle. It is opposite the biggest side. And that's the one thing you want to pay attention to when you're finding these answers. Biggest angle, biggest side. Those should correspond. Medium angle, medium side. 7 is in between 5.97 to 10. Smallest angle, smallest side, and that is what it should end up looking like. So that is law of cosines right there. All right, now we're going to look into another logarithm type problem. And what we're going to use here is, to me, I think this is cool because this is where we start actually using our understanding of logarithms to solve for stuff. And so what you're going to do is you'll actually bring in log. You'll go log 10 negative 2x plus 2 equals log 8. So you brought the logarithm into this thing. And what we're going to do is we're going to take this and bring it here. So we'll have negative 2x plus 2, which you know with your rule of logarithms that is legal. And so what you're going to do is you're going to take the log of 10 and the log of 8. It's going to give you a decimal. And you're going to solve for this just like if it were a normal problem. And whenever you do this, you're going to get now the log of 10 actually ends up being 1. And you'll see that in your calculator. And then the log of 8 is a decimal number. And the log of 8 is 0.9031. And then you would just solve for this like you would a normal problem solving for x. We get negative 2x plus 2 equals 0.9031. Subtract 2 from both sides. You get negative 2x equals negative 1.0969. And then x is going to equal a positive number, 0.5485. So I like this because you get to actually start using logarithms and you understand the purpose of it. Lesson 83 is the last lesson in this set, and it is simple probability. All right, and so you're going to want to look in your books in order to look at this. This is actually old school stuff that you've done for a long time. Kind of takes a break from all the pre-cal and trig and different things we've been looking at. The first question, example 83.1 says 2 dice are rolled. Okay, so 2 dice are rolled. What's the probability of getting a 7 in one of them and then a number greater than 8. Okay, so we've got 2, your dice 1 is a 7, dice 2 is an 8. Well, you've got to go to this chart right here, and if you'll notice, there are 1, 2, 3, 4, 5, 6 possibilities of a 7 divided by the possible number of outcomes. So 7 divided by 36, total outcomes. And then the other one is greater than 8. So it would be 9, 10, or 11. So when you look up here, you look at the 9s, the 10s, or the 11s. I see 1, 2, 3, 4 9s, 3 10s, 7, 8, 9, 10. So you have 10 possibilities of greater than 8 divided by 36. So these are your two answers. 1/6 was the first one, and in the second one, it would be 5/18. So these are your two possible outcomes here. Simple probability. All right, the next one is independent events. It says a fair coin is tossed 3 times. What is the probability it comes up heads every time? Well, it's a half the first time, a half the second time, a half the third time. 1 out of 2. Multiply them together, it's a 1 in 8 chance that all 3 times is going to be an 8th. So that's the way that would work when they You know, the first one, these were just independent rolls of the dice, but these were they hinged on each other for the outcome. So you're going to multiply those together. Then the last one is with a deck of cards or with marbles. It says 2 cards are drawn from a 52 card deck without replacement. What's the probability that the first one is red? Okay, the first one is red. Well, there's 26 red cards out of a 52 deck of cards. And then they want to know, what's the probability that the second one is black? Well, that's going to be 26 divided by 51, because it was a red card, supposedly, that was taken out of there. And so you multiply those together, and you're going to end up with 13 over 51 as your probability when you multiply those together. So this is just something, maybe just a little bonus to throw in there and take a break from the pre-calc. Those are all the lessons from 80, 81, 82, and 83.